As Tanjiro swings those sharp-bladed swords toward the demon's neck, his every motion forms a perfect arc, precise, fluid, and balanced. If you look closely, the path his sword follows mirrors one of the most elegant curves in mathematics, the parabola.
Good morning, everyone. Praise be Jesus and Mary. Welcome to the vertical parabola art, where we'll uncover the beauty and precision behind one of math's most graceful curves. This video, we'll be discussing the parabola in its standard form, focusing on the vertical parabola, the one that opens upward or downward, just like the rise and fall of Tanjira's sword in battle. So what exactly is a parabola? A parabola is a U-shaped curve formed by the set of all points that are equidistant from a fixed point called the focus and a fixed line called the directrix. This unique relationship gives the parabola its perfect shape, one we can see all around us in real life. The arc of a basketball shot, the stream of a water fountain, the curve of a satellite dish, or even the beam from a car's headlight. Now that we know what a parabola is, let's move on how we graph it. But before we dive in, we're going to use a special briefing style called Vogt-Trick our step-by-step technique for mastering the parabola. Each letter in Vogt-Trick stands for a key move. V for vertex, O for opening, F for focus, trix for directrix, and thumb for latus recta. Just like a demon slayer mastering their breathing style, we'll use Vogt-Trick to stay focused, precise, and ready to conquer any parabola that comes our way. Briefing style, parabola form, Vogt-Trick first technique, graph manifestation. There are 5 important steps to follow when graphing a vertical parabola. Step 1. Plot the vertex, or HK. This point is the heart of the parabola. It shows where the curve changes direction. Step 2. Identify the opening, whether it opens upward if A is positive or downward if A is negative. Step 3. Locate the focus. This point lies inside the parabola and helps determine how wide or narrow the curve will be. Step 4. Plot the directrix, a fixed line opposite the focus that defines the boundary of the curve. Step 5. Solve for the latus recta. This line segment passes through the focus and helps us sketch the width of the parabola accurately. By following these 5 steps, our Vogt-Trick form, we can see how a vertical parabola works, guided by its vertex, focus, directrix, and perfect symmetry. Now, we're going to use the standard equation of a vertical parabola. Opening parenthesis x minus h closing parenthesis squared is equals to 4c opening parenthesis y minus k closing parenthesis. This equation helps us determine whether the parabola opens upward or downward and allows us to identify the vertex, focus, directrix, and latus recta. Now, let's put our understanding into action by applying the standard equation of a vertical parabola. For our first example, we have the equation opening parenthesis x minus 1 closing parenthesis squared equals 12 opening parenthesis y plus 2 closing parenthesis. This equation represents a vertical parabola, and since C is positive, then it opens upward, just like how energy rises before a powerful strike. Step 1. First form, vertex strike. Following the 5 steps of graphing a parabola, the first thing we identify is the vertex, represented by the values of h and k. All we need to remember is that x is always paired with h, while y is paired with k. So in our equation, opening parenthesis x minus 1 closing parenthesis squared equals 12, opening parenthesis y plus 2 closing parenthesis, we can see that h is equals to positive 1 and k is equals to negative 2. But wait, why did the sign change? That's because in the standard form, opening parenthesis x minus h closing parenthesis squared equals 4c opening parenthesis y minus k. The signs of h and k flip when we extract them from the equation. Inside the parenthesis, we have subtraction, meaning if the equation shows opening parenthesis x minus 1 closing parenthesis, h is positive 1. But if it shows opening parenthesis y plus 2 closing parenthesis, we rewrite it as opening parenthesis y minus opening parenthesis minus 2 closing parenthesis, so k is equals to negative 2. Therefore, our vertex is 1 and negative 2.
Step 2. Second form, opening reveal.
The second step is to identify the opening of the parabola. To do this, we simply look at the value of c, which in our equation is represented by 12. If c is positive, the parabola opens upward for vertical or to the right for horizontal. If c is negative, it opens downward or to the left, the opposite direction. Since our value of c is positive, then that means our parabola opens upward.
Step 3. Third form, focus summon.
The third step is to find the focus of the parabola. To do this, we use the value of c, which we can get from the equation opening parenthesis x minus h closing parenthesis squared equals 4c opening parenthesis y minus k closing parenthesis. In our equation, the number 12 represents 4c. So to find c, we divide 12 by 4, giving us 3. This means the focus is 3 units away from the vertex, along the direction in which the parabola opens.
Step 4. Fourth form, directrix line.
The fourth step is to find the directrix of the parabola. The directrix is a fixed line that lies on the opposite side of the vertex from the focus. It's also the same distance away as the focus, just in the opposite direction. Since our c is equals to 3, and our parabola opens upward, the focus is 3 units above the vertex. So that means that the directrix will be 3 units below the vertex. An easy way to remember this is that the directrix has the opposite sign of c compared to the focus. So if the focus is positive 3, then the directrix is negative 3.
Step 5. Fifth form, latus rectum expansion.
The fifth and final step is to find the latus rectum of the parabola. The latus rectum is a line segment that passes through the focus and helps us determine how wide the parabola is. To find its length, we simply multiply 2 times c. Since our c is equals to 3, then we have 2 times 3 giving us 6. That means the length of our latus rectum is 6 units.
Now that our rough trickstone is complete, we can finally bring our parabola to life on the graph. To find the vertex, start by moving 1 unit to the right and 2 units down. This marks our vertex at positive 1 and negative 2, the heart of our parabola. Since our value c is positive, this indicates that our parabola opens upward. Next, from the vertex, move 3 units upward. This is our focus. Then, to locate the directrix, move 3 units downward from the vertex. This gives us the line y is equals to negative 5. Finally, the focus counts 6 units to the left and 6 units to the right. This represents the latus rectum, which helps us sketch the full width of our parabola accurately. And there you have it, the complete form of our vertical parabola, perfectly balanced like a sword strike in motion.
Now that we've completed all the steps, this is what our parabola looks like. Opening gracefully upward with its vertex, focus, directrix, and latus rectum in all perfect balance. You can clearly see how each part works together to form that beautiful U-shaped curve, just like the motion we saw earlier in Tanger's sword's width. Now it's time to test your skills. Let's try another example. This time, a vertical parabola that opens downward. Can you solve this equation and identify its vertex, focus, and directrix? Notice that negative sign? That's your clue. It tells us that the parabola opens downward. Use the same Wolfrich stone steps. Vertex, opening, focus, directrix, and latus rectum. And show that you can wield this mathematical breathing form with confidence and precision. And just like that, we've conquered the vertical parabola arc. We've learned to find the vertex, determine its opening, locate the focus and directrix, and solve for the latus rectum. Each equation may differ, but the process stays the same. Just like how every demon slayer has a unique breathing style, yet shares one goal: math. So whether your parabola opens upward like hope or downward like challenge, every curve tells a story of balance and precision. Keep sharpening your mathematical blade, because next time we'll enter the horizontal arc, where the parabola shifts direction in a new form.